if our goal is to make a simulation module, we want to create interesting logic that does interesting things. And again, for this workshop, we're going to just be doing a simulation that calculates occupancies by multiplying gross floor area by occupant densities that we will be specifying outside of the normal UMI settings. We do that like we do everything else within Visual Studio. So let's go ahead and close this and get back to our command. So our command file is over here. And here's it not doing anything useful. Our goal is to instead calculate better occupancies. And we're going to do that using, as a first step, the built-in UMI occupancy numbers. So we go ahead and delete this. We're gonna, delete this app.writeLine thing. We're gonna start going through using properties in this UMI context object here. And this is how you access things that are in the currently loaded UMI project. This context has a lot of fun things, which you can find by typing context.period and using the IntelliSense. These are all the cool stuff that you can get out of an UMI project that's currently loaded. We will not be using the vast majority of these in the demo today. What we're going to do is we're going to go through the UMI buildings. And another thing we're not going to do here is implement selection logic. We're not going to create a command that when you run it only runs over the buildings you select, the way most Rhino commands work. That would be a good idea, but it is off the beaten path in terms of what we need for our UMI module demo. For this demo, we're just going to calculate occupancy for every building without attention to what the user has selected, just to make things a little clearer. So we're just going to go through each building in the currently loaded project's buildings. Okay. Context.buildings.all. And for each building, to calculate the occupancy, we want two things. We want our gross floor area, which UMI has already calculated for us. And we want our occupant density, which UMI also has found for us, because these are built-in UMI values. As we get through later steps in the workshop, we're going to stop using the built-in UMI occupant density. We're going to use our own. But for now, we're just going to use the one that UMI is providing. And that means the occupancy is the gross floor area times the occupant density. So when we run this simulation, quote unquote, we should get the same value that UMI gives us in that UMI building settings panel. We'll verify that once we actually launch Rhino. But first, we have to do something with this occupancy. And the first thing we can do is we can just print it to the console using Rhino app.writeLine. And I'm going to use a C# interpolated string with a $sign. Okay. And I'll say building.name and then occupancy. So here, what this will do is it will go through, and for each building, it will calculate that building's occupancy, and then it'll just print to the console that building's name followed by its occupancy. Okay. So let's see if that works. We load our project up. So here's our building, our office building. UMI thinks that there should be 37 occupants based on this building's gross floor area and the occupancy that came out of its template, the occupant density that came out of its template. Let's see if our module agrees. Office, 37 point, well, it didn't round it the way the UMI panel rounds it, but the numbers are the same, 37 people. So that's great. Let's make a couple more buildings and make sure that this is working all the way it should. So we have our office. Let's make some retail. And let's make some residential as well. Our command. Now we get 3 values, 15 people in retail, are 37 in the office, and then the residential has 7 people, like it should. So we have successfully changed our command logic to actually interact with the loaded UMI project. We retrieved the buildings, and we calculated the gross floor area and the occupant density, and then used that to calculate occupancy. I'm sorry, we didn't calculate these. We retrieved them from UMI and used them to calculate occupancy. This is a very simple command that reads from the currently loaded UMI project. And in the next sessions, we're going to do more complicated things with the UMI project, such as saving data to it.